Hello everyone, welcome to the Nexus QI. We have just started the new channel. The purpose of the channel is very clear. There are so many channels are there in educations, but we have started the Nexus. The purpose, we have to give so many exams like the NTSC and other competitive exams. The problem of all the exams is physics. The major of the problem start with the physics. So we have just start with one chapter of the physics of class 10th, and we will start this with the new concept and with all the layer technique what we have done from past 10 years, and we will see how we can make it totally different from compared to any other educator. Okay, so we have started the chapter called electricity of class 10th. Anyone can learn from, the student can join from class 6, 7, 8, 9. Question is very simple. If you understand the basic few points, charge, current and voltage, if we know three things, it's more than enough to understand entire chapter. So our focus will be on three things. What is charge, what is current and what is voltage. So we will see one by one what is the difference and how they are different from each other, or is there any relation between these. If we know the relation, what are the three things? If we know the relation, then it will be very easy for us to understand the entire chapter. So without bothering, we will understand three major concepts: charge, current and voltage. So here, so everything is made up of matter, it's clear. Each and everything is made up of matter. And how matter is made up of? Matter is made up of small particles called atoms. It's very clear, it's very simple. Now, if we go inside the atom, what we will see? While going inside the atom, we will see outside some electron will be there and inside neutrons and protons will be there. So this is the basic structure of atoms. Everywhere electrons will be there and inside neutrons and protons will be there. How these things play important role in electricity? This is the major question. From where we are where they are getting the energy to do so. One by one we will clear it. Now, first, what is electron? Electron is fundamental unit of atoms. So this is the electron. On the head of the electrons there will be some charges. Suppose this is the charge, it's carrying some charges, and each and every electron is having some charge. So this is the electron again, just try to understand, and there are some charges on his head. Whenever we will see the electron, there will be charges on his head, clear? Now, it has some value and magnitude. It has some value and magnitude of on each and every electrons. Here game starts from here. So each and every electron, suppose we have some charges. Now what is the role of charges? See, if we have n number of electrons, so we have to multiply with the charges. This is the number and this is the charges it contains. So plus minus any, plus or minus any, we will see it. So now one by one we will make it clear. So we understood everything is made up of matter, and if we go inside the matter, atom will be there, and there are three particles present in the atoms: electrons, protons and neutrons. But in this chapter, electron play important role because each and every electron have some charges. That is the very clear part. Now, suppose this is a copper rod. So we can say we have one copper, a small rod. So this is the copper rod. So this is made up of full copper and outside coating is there. So my question is simple. Now, is this wire carrying any current? Yes or no? Now, if we connect, are electrons running inside? So these are the fundamental questions. Why the current flow in the copper wire, not in the plastics or any insulating wire? So we will just try to clear this. First of all, the copper atomic number will be 29, right? The atomic number of copper will be 29, and now there will be one free electrons. This is a copper rod, and there will be one free electrons everywhere. That is not bounded by this nucleus. Now this electron can freely move little bit from here to where. We can say it in higher classes we will see the drift velocity, but for you just see this electron is keep on moving little bit. They are allowed to move. Why? Because protons are not having, they are not applying more force on this electron. This is a simple concept. They are allowed to move. They have not, but this is the free electrons, right? Now, after that, if they keep on moving, then why we are not feeling the current? Again, if they have permission to move, they are moving, so why we are not getting the current? Now, the answer is very simple. If we connect with some sources, sources means energy. If we are going to connect with any type of sources, battery sources, then we will see the difference. And now if we are going to touch this copper wire, we will get a shock. So, entire thing is based on the movement of the electron and who is forcing electron to move. Okay. So, now one by one we will see who is forcing the electron to move. So, this is a copper rod without having attached with any type of energy sources, and now we have copper wire that is attached with the energy sources. The major difference in between, what is the major difference? This is also made up of electrons, and in this also electron is there. But see the difference between this electron and this electron. This electron is moving. Why these electrons are moving? Due to the energy source. Energy, the energy provided by the battery, it make it move. Here we have not connected anything like the energy source. So they are moving by themselves, but little movement. They are allowed to move, but in between somewhere. But here we will see the maximum movement. What is the reason for the maximum movement? The energy. So one thing is very clear, electron will move, and according to this concept, who will allow to move the electrons? Who will provide the energy? Voltage will provide the energy. But one more thing, this voltage, what is present inside this battery? We will see. Suppose we have the battery like this. What is present inside the battery? So if we look inside, so we have seen there will be some positive charge and there will be some negative charge. Both will be separate. Okay. And the charge only, this is the charge that apply the field. Due to this positive charge only we are going to get the field. Okay. So positive charge field produce karta hai. And field, the meaning of field is nothing just like a force. You just understand field is nothing just a type of force. So automatically each and every positive charge apply one field, and this field is nothing, this field is just a force. And we look this structure, force is produced by this source, force is going to produce by this source, that is called battery. Now what is happening inside the battery? Some chemical reactions are happening, not in our syllabus. Some few chemicals reactions are happening inside the battery. But one thing is very clear in the battery, there are two potential, positive end and negative ends. Due to this two potential, we are experiencing a field inside only. Okay. So now the major question is, how this field going to help? How this field is going to help the electron, the charge to move? We will see how this field is helping the electron or charge to move in entire circuit. So a small briefing, everything is made up of matter, and inside the matter atom is there, and inside the atom, if you go inside the atom, there will be proton, neutron and electron. But in this chapter from the beginning I am telling electron play important role. Due to the electron only the current will move. Why electron is moving and who is applying the force, who is giving the energy? Battery. We have seen this battery is providing the field. And what is field? So any positive charge is present, so they itself have this property of field. Any positive charge have this field, and if we draw the negative charge, the field will come inward, and positive charge, the field will go outside. This is the major reason for the movement of charge or electrons. Now another thing we have seen, if we draw the electron, we have to draw something called charge on their head. Okay. So, these are the very fundamental and this is the core of the chapter. If we know each and every electron contain charge, one thing. Second, if charge have to move, they have to provide some energy. What is energy? Energy is nothing, just a experience of force. And who is applying the force? Battery is applying the force. Inside battery, what is present? Positive charge is present, and due to this positive charge only, battery is applying force. Now, it's very clear, any movement of electron, any movement of charge happening due to this positive field. And what is the positive field? This positive field is a electric field, okay, and from where we are getting? We are getting it from the charge. Now, what is charge? Simple. So, this is the definition of charge and we have to decode this definition. How we can decode this definition? This is the Q and this is the positive. It can be positive or negative. Suppose we are going to rub any particles or any matters. So, either two things can happen. Either the electron from the pen to come to this, and second, from here the electron can come to this pen. So, we have two probability. Exchange is happening. If for exchange we are using the positive or negative, either gain or either loss. Kiska loss, kiska gain? We have the electron, and how many electrons? For that we have the number. So, it is very clear. We have decoded the formula. What is the purpose of the formula? Charge. When the charge is produced, when we will gain and loss. Kiska gain and loss? Of electron, and this is a quantized material. So, we have the proper number 1, 2 electron, 3 electron. So, this is no need to mug up this. This is the charge. What is the definition of charge? No need to mug up, plus minus Ne is very clear. Gain and loss of electron, and this is the number, how much. So, this is only going to move, and who is going to move it? From where they are getting the power to move? Positive, or we can say electric field. Where electric field is producing? In each and every cell or battery, electric field is producing. So, charge is doing nothing from themselves, they are just following the field produced by the battery. Now, we will come to see what is happening and how we can move any charge. So, for that I will give you one example. Suppose this is slider, and compared to this I am drawing some circuit also to make you understand both at a time what is happening inside the circuit and how we can decode this. Everything we have to decode. First we have decoded the formula. How we have decoded? Charge is gain and loss of electron and their number, and unit is coulomb. Second, we are going to decode this. What is voltage? For this we have the simple example. Suppose there are some students, and consider this student as a charge. Okay. So, first it will jump and it will come here, and automatically it will come down. It will come down here. Again they will try to reach it here, again it will come. So, from here to here they are not using so much of energy, but from here to here the potential is very high, and this is, we can say this is low potential and this is high potential. Same in the battery, one side is high potential and one side is low potential. Now, there, suppose in any case we break this part, and now it depends on the parents, and parents have to keep it here. So, parents have to apply some work or they have to do some work. किस पे work करना होगा? इस चार्ज पे. इस चार्ज को उठाना होगा. They have to keep it up and they have to keep it here. For doing so, they will utilize some energy. Work done. किस पे work done? Charge. Work done on charge. That is only called voltage. It means inside something is working on the charge. Work done on the charge. Okay. Now, their unit will be volt. It's very clear, but for making you understand, we have to give one another example. Suppose I will tell you to go and get 10 volt battery, and for other person I will tell go and to get 20 volt battery. So, I will give some assignment to two people, go and get 10 volt battery and 20 volt battery. Now, they have to understand what is the meaning of 10 volt battery and 20 volt battery. It is very clear now because we have decoded the formula. 10 volt battery means 10 joule of work per charge. 20 volt means 20 joule of work per charge. So, we have cleared this also. 10 volt means 10 joule of work per charge, 20 volt means 20 joule of work per charge. So we have started from the charge, electron contain charge. Now, who is pushing the charge? There is something inside the battery, that field that is pushing the charge. And what is the meaning of voltage? Work done per charge. It means from here, battery is pushing the electron and again electron is coming its way, again a battery is pushing it. For doing so, if we see the battery, there will be positive and there will be negative terminal. Positive terminal means suppose this is a 10 volt, so this is 10 and this is 0. So one side should be having the maximum value and another side having the minimum value. Now, in next concept, we will try to understand, what we understood till now, what is electron and how it contains the charge. Second thing, who is forcing electron to move. Okay. So, electric field is the new concept. That field is going to produce, and from where the field is going to produce? Field is going to produce by this positive charge Q. And who is pushing? The field is pushing the charge. In next concept, we have to see how the charge is moving. First, this is the electron and electron carrying the charge, and after that we have seen what is the unit of charge and what is the formula of charge. From here we have started plus or minus Ne, number of electron gain or loss. After that we have seen who is pushing this charge. For that we have the voltage is pushing the charge. What is the voltage? Voltage is nothing, work done. किस पे work done? On the charge, work done on charge. So everything started from the electron. See how we have connected. Everything started from the electron. Electron are having charge, is already naturally made. We have not done anything. So electron having the charge. It's a universal truth. Now, what is charge? We can say each and every material will be neutral. But if we rub something, there is chances that we will gain or we will lose the electron. So gain or loss of electron is called charge. Okay. Now, who is applying force on the charge? Battery is applying force on the charge. What is force? Force is developed by the field. Okay. From where we are getting the field? Each and every positive charge, they are having field in this direction. So now we have seen till here what is voltage. Voltage is work done per charge. Next concept, if we are moving something, there will be some collision. There will be some collision will be there. Electrons in the wire, the electron keep on colliding. So from there we are getting one concept, that is called resistance. Due to the collision, heavy collision of the electrons among themselves, or there may be other reason. What may be the other reason? The impurity is present inside the wire, or there may be some gap, or it may be so many other regions are present. But in your syllabus, what is the reason for the resistance? Collision, while movement of charge, while movement of electron, they will collide with themselves. Okay. And after the collision, we will see some factors we are getting, that is the resistance. In one word or in simple word, we can say this is the speed breaker. This is the speed breaker that stop or that make the speed of the charge very simple, or it make it slower. Okay. Now, from where we are getting this R? Actually, we are getting this R from the Ohm's law. What is Ohm's law? If we keep on increasing the voltage, current will, we will experience a more current, more voltage, because more work done. We have just given the example. Faster we will put it, the student here, again it will come, again we will put, again it will come. So more voltage, more current. So for removing this sign, V is equal to IR, and from here R is equal to V by I. So this is the resistance, but in your case, this is just a speed breaker. Just think it is a speed breaker. It's make the speed of charge, it make it slower. Okay, it's not helping, it's make it slower, just like the speed breaker. So now we have the two concepts in this. The length of wire decide the R. If length is longer, probability of R will be more. If length is shorter, the R will be less. So we can say that R depend on the length of the wire. One factor. Second factor, The radius of the length also play an important role. Suppose this is the radius of the wire, and if the radius of the wire we are making the smaller, now smaller the radius, more will be R. Bigger the radius, less will be R. It means there are only two factors, and there are other factor also, we can say temperature, okay, but majorly two factor from where we are getting the formula. So we can write R is equal to rho L by A. Again this is a formula, it means we have to decode the formula. From the beginning we are decoding each and every formula to understand it, okay. So I am going to decode this formula. First we decode plus minus Ne, after that we decode what is the voltage, work done per charge, Now we are going to decode the formula R is equal to rho L by A. See, length directly proportional, we can say directly proportional to the resistance. Longer the wire, more the resistance. We can say cross section. So length, cross section means area, pi r square. It depends on the r. If more the radius, okay, less the resistance. If resistance is high, it means radius is low. If the radius, okay. So from where we are getting the two relation. So we are just adding the two relation. R is equal to L by A. It directly proportional to the L and inversely proportional to the area. Okay. Now, and this is the sign of resistivity. It depends on the material. We can't change this. For copper wire, they have the different resistivity. For aluminum wire, we have the different resistivity. This is a simple thing. R, we can say R is equal to rho L by A. Now, we have seen how we can change the R resistance by increasing the length of the wire or decreasing the length of the wire, or just increasing the cross section of the wire or decreasing the cross section of the wire. Maximum we can do this thing. We can use the formula, and we have decoded the formula how there is relation between L and how we are getting the relation from the area. Clear? Now, one thing, and this is the very important thing, in the circuit can be considered the resistance of the wire. For your syllabus, we are not taking any resistance from your wires. We are neglecting it. Okay. Then what is, from where we are getting the resistance? So all the appliances we are including as a resistance, because all the appliances consume energy, and after consuming energy they produce the heat. Okay. So from where they are going to get the heat? So because they are consuming the energy, and byproduct is heat. Now, how we can calculate all the resistance? For calculating, we have to check the circuit. If all the resistance are present in the series, so we have to make it R1, R2, R3. If they are placed in the circuit in this way. But if resistance are placed in the parallelly means in this way we can't add it simply. For adding this, we have to take reciprocal, suppose R1, R2 and R3. How we are going to add? 1 by R is equal to R equivalent, total is equal to R1 plus 1 by R2 plus 1 by R3. So we have only two methods. Either we can add directly. How we can add directly? By adding all the resistance 1, 2, 3 or n number of resistance. Second, how we can add this? If resistance are attached in the parallel, 1 by R1, 1 by R2 plus 1 by R3, or it will go to the n number of. Now, after getting the final answer, we have to reverse it, because we are getting the answer of 1 by R. So till here we have seen all and each part is connected with a simple concept, that is the charge. And from the beginning I am telling electron contain charge itself. Only we are pushing the charges, only we are pushing the electron, and for pushing which is responsible for all the movement energy sources, and that is the battery. This is the energy sources. And while running, while moving, there is some speed breaker. That speed breaker is nothing called resistance. If they are present in the series, we have to add it. If they are present in the parallelly, we have to reciprocal, and we have to again inverse the final answer. Okay, till here everything is clear, I hope. And what is unique? What we have done unique? We have decoded each and every formula. We have never mug up any formula. I didn't give you any formula directly. We just decode each and every formula from where we are getting the formula. Okay. Now we have only last two formula left, and each and everything we can say electron and the charge. It is very simple, because we know electron having the charge. It is universal truth. Charge, someone is going to push the charge. That is the energy. Okay, from where we are getting the energy? It may be any source, battery source. Okay. Now, while movement, while running, the charges, we have some disturbance, that is called a speed breaker. Okay. If a speed breaker are arranged in series, we have to add it. If they are arranged parallelly, then we have to reciprocal it, then add, and again final answer will be opposite. Last, we have only two things left now to understand what is power. Okay. So we have, again we will decode this, what is power. Okay. So suppose I will take the three students, Ramu, Gopal, Syam. I will assign some work, Ramu, Gopal and Syam. This is Ramu, this is Gopal, and this is Syam. I am going to assign some work, but if I will tell them to go and push up, they will come and report me, sir, I have done this much push up, this 10, 20, 30. But even though we can't find out the power, because we have not given the time limitation. Okay. So they will do with their own pace. But if same task, if the task I have given for the push up to the Ramu, Gopal and okay, after giving the same task, if I am going to divide and I will finalize the time, you have to do in only 1 second. So I will divide that, I will just give the time of only 1 second. Now the report we will get, that will be the real, and this decides the power. Then suppose 10 push up, 20 push up in 1 second and 30 push up. Now it's very clear, in 1 second who is doing more push up? This student is going more push up in 30 seconds. In 1 second, I have just divide each and every with the 1 second. In 1 second 10 push up, in 1 second 20 push up, in 1 second 30 push up. Who is more powerful? This third one is more powerful. So from here we again we converted and we derived the formula, power is equal to work done by time. No need to mug up again. Power is equal to work done by time. But there may be some interconversion of the formula. For that also you should no need to mug up any interconversion. How we can convert one formula into other formula, we are going to learn. That is called interconversion chain. Now, we know that from the beginning, we have seen in the beginning, voltage is equal to work done per charge. Some parents was pushing or pulling the students. So work done per charge. From here, what is the formula of work? Work is equal to, just cross multiply, V into Q. And we know that what is the charge? Again, everything coming to the charge. Charge is equal to N and Ne. Okay. So how there is some relation between this and this, because in this also we brought the concept of charge. Okay. So work done by time. This is the formula of power. Work done by time. Next is heat, and this is the last concept of heat. Again the formula will be I square RT, and you know from the beginning of the class I am just decoding the formula. I am doing nothing, I am just decoding the formula to make it very, very simple. Again I have to decode this formula, from where we are getting the formula, and this is the last formula, I square RT. Suppose again I will give some example, like we took the two bulb and one bulb is blowing from 10 hour and one just now we have switched on the one bulb just now. So 0 hour we can say, or 1 initially. So common says in which bulb, this is the bulb A and this is the bulb B. One thing In which ball do you think there will be more heat? Definitely ball way. It means heat is directly proportional to the time. Longer the hour, more heat will produce. Second thing, if I will provide more resistance to the bulb, again more the resistance, more the heat will produce. Again H is directly proportional to the R. R is called resistance. And third and finally, more the current, more the heat. But current we will have to take in the square form, double of the current. So again H directly proportional to the I square. Now we club all three together. So we got the formula H is equal to I square RT. Okay. So from the beginning of the chapter we have seen how we have decoded the formula. Just I will give you the quick glimpse of decoding. Okay. So this is the electron, and electron contains charge. It's universal truth. Someone is going to push this electron. With electron, charge is also going to move. And who is someone? So for this charge we have the formula called Q is equal to gain and loss of electrons, and the unit is coulomb. And finally someone is going to force it. Who is going to force? The battery, the energy source. For that we decode the formula voltage is equal to work done per charge. And finally after that, if something is moving, definitely there will be some problem. They are going to face some problem. That problem is called speed breaker, that is the R. And we know that R depend on the few things, length of the wire, it depend on the cross section of the wire. So from there we derive the formula R is equal to L by A. Just we have decoded the formula. After that, there are two type of resistance. Resistance means if we have to arrange in the series, we have to do R1 plus R2 plus R3, and if the resistance are in the parallel, then 1 by R equivalent is equal to 1 by R1 plus 1 by R2 and 1 by R3. Finally, we have seen what is power. Power is, we have just decoded the formula, power is work by time, and from there we reach heat. Heat is equal to I square RT. We have just convert each and every formula and we just decode it into a simple way by giving all the examples. So the 10th syllabus look like very difficult. There are so many formulas are there, and for understanding the formula, the concept should be clear. If we are looking for a small concept, so these are the small concepts. If you are thorough to this all concept, a small story, the chapter you are very clear. The chapter will be crystal clear for you. Okay. So hello friends, we have seen how we have concluded the entire chapter in a very unique and fun way. Each and every section was related with some story. For if you have any particular doubt or you want to give me a new chapter so that I can form a new formula or new story, kindly comment and write particular chapter names. So I am ready here for do innovative tasks for you and creative tasks for you. So please like, subscribe, okay, and comment. And if you have any problem in any chapter, send to us and mail us or comment us so that we can start a new story for each and every section. Thank you. Have a great day. Thank you.